So now that we've talked about triangles, special right triangles and right triangle trig, we want to be able to put that onto the unit circle. But before we can start the unit circle, we need to look at some parts of the unit circle. So get the basic understanding of angles on a coordinate plane. But don't worry, we won't be graphing anything like a polynomial, we'll just be using the coordinate plane. So we need to recall our coordinate plane. It has two axes, an x-axis and a y-axis. My y-axis is my vertical axis, my x-axis is my horizontal axis, and we have four quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is going to be important. What we're going to talk about is graphing an angle on this, okay? And so, on a coordinate plane, an angle may be generated by the rotation of two rays that share a fixed endpoint. Now when we graph on the coordinate plane, that fixed endpoint will be the origin. So we want to start to think about an angle. So we've got this angle right here. This is going to be their vertex, which is going to be their shared endpoint. This is going to be the rotation, which will be our angle theta. And then we have two parts. We have our initial side, which is our initial ray, which is a fixed ray along the positive x-axis. It's always going to be along the positive x-axis. And then we have our terminal side. Terminal meaning ending, so it's the ending side. So, terminal side. And that's going to be the rotated ray. Now when we work with the unit circle, all of our angles are going to be in what's called standard position. And you want to be familiar with this terminology. That's going to be an angle whose vertex is on the origin and the initial side is on the positive x-axis. So let's look at an example of what an angle might look like if it was in standard position on the coordinate plane. So I'm going to draw a little sketch of a coordinate plane. I'm going to get my initial side along the positive x-axis. My vertex is always at the origin. And then I'm just going to draw my terminal side, where the angle is rotated this way with theta. Now, we need to put some degrees here so we can get an understanding of how big our angle is. Now you know that a right angle is 90 degrees, an obtuse angle is bigger than 90 degrees, and an acute angle is between 0 and 90 degrees. So when we look at this, this is 0 degrees. This is going to be 90 degrees because if I were to draw a right angle box there, this is going to be 180 degrees, a line is 180 degrees, and this is going to be 270. Then we can also say this would be 360. So if you notice, if I were to start here and go all the way around, I make a full circle. If I only go to here, I make 180 degrees. If I go to here, I make 270 degrees. So we want to get this idea of 0, 90, 180, 270, and 360 into our mind. Now, we need to name another angle, just to get it in our brains right now. We have what's called a quadrantal. Because what if my angle ends on 90, 180, 270, or 360? That's called a quadrantal. It's an angle whose terminal side is on or is along an axis. So any angle that falls on an axis. And then we have two ways that we can look at these, okay? We're going to have positive angles and negative angles. And not like positive as in good and bad, positive as in the degree. So we'll have positive here, and I'll draw my little coordinate plane. A positive angle is going to go counterclockwise. If you don't know which way counterclockwise is, look at an actual clock. So it's going to go this way. So we would have 90 degrees here, just like I'd already drawn, 180, 270, 0, and 360. So the angle would go like this. The other option that we have is we have a negative angle. So I'm going to draw another coordinate plane. You're going to have to be very good at drawing lots of coordinate planes. And if a positive angle goes counterclockwise, you should assume, and would be correct to assume, that a negative angle goes clockwise. So our negative angle is going to go this way. Now we need to relabel the axes. So this is still going to be 0 degrees, but we're going in the negative direction, so now this is negative 90 degrees, not 270. Then we're going another 90 degrees, so we're going a negative 180. Up here is now going to be a negative 270, and we'll have negative 360. This is going to be a concept that's a little challenging for you to understand, but the more practice that you do with it, the better you get. So we want to practice with it, okay? Now let's do some examples. When I do my examples, I highly suggest that you always draw your 4 quadrantals, 0, 90, 180, and 270. So here's example A. And we're going to plot 195 degrees. And we're going to determine what quadrant it's going to fall in. So I'm going to draw my coordinate plane like I'm going to do for every single problem. I'm going to be sick of drawing these. And I see that it's 195 degrees, so it's positive. So it's going counterclockwise. So I'm going to draw my initial side, and then I'm going to label my quadrantals. 0, 90, 180, 270. Well, 195 is going to be more than 180, so I know I have to go to here. But it's going to be between 180 and 270. So I'm going to draw my terminal side here. And that's going to be, this is quadrant 1, 2, 3. So this is going to be in quadrant 3. Now is when I'd ask if you have any questions, but unfortunately right now I can't answer them. So we'll move on to example B. And here we're going to look at negative 300 degrees. So drawing our coordinate plane over and over and over again. And drawing our initial side and then labeling. Now remember, we're going negative, so we're going this way. So now we have negative 90, negative 180, negative 270, 0, and a negative 360. So it's 300 degrees. So I know 300, and when I say more than, I mean it's going to be further in the negatives. So it's going to need to go further in the negatives for 300, or more than negative 90. And so we're going to keep going until we get to a negative 270, and negative 360. Well, our angle is going to fall in there. Now I'm not looking for it to be perfect, but I have to make sure when I draw this that I do not draw it like this. If I were to draw it like that, that would be bad, because that would insinuate that it's a positive angle. This is a negative angle, so we have to go around here. And that's going to be in quadrant 1. Now let's look at example C. So we've got negative 93 degrees. Trying to give you a couple negative examples so that you get some practice with that, because understanding the negatives can be a little challenging. So we're going negative. So I'm labeling negative 90, negative 180, negative 270, 0, initial side. Now, negative 93 is going to be a little bit past negative 90. So that's going to be in quadrant 3. And our last example for these before we move on will be, I should have wrote the angle first, oops, 180 degrees. This one should be easy, but it's just to get in the idea of naming them special things. So it's a positive 180, so I'm putting my initial side here, 90, 180, 270, 0, 360. Yes, I've forgotten my degree symbols on almost every single one, but you get the idea at this point. So to get to 180, it is going to be a straight line. I want to make sure I draw it on the correct side, and that is going to be a quadrantal. So that is the basics of understanding the different types of problems. Now on your worksheet for today, numbers 1 through 26 on the worksheet will be for practice on this. The last thing that we want to talk about is coterminal angles. So, before I introduce coterminal angles, I want to give you I'm going to pose a question to you. What if I give you these 3 angles? So let me draw the angles, and then we're going to talk about them. Gotta draw my coordinate planes every time. That guy's a little far. So I've got 45 degrees. It's positive, so it's going to be in quadrant 1, and it looks like that. Then I've got a negative 315 degrees. So this was a negative 270. This was a negative 315. So I know, or sorry, that's 360. I don't know what I'm thinking here. So then 315 is going to go in here, but it's going to go this way. And then I've got 405, which is a little bit different because if you think about it, there's only 360 degrees on a circle. So I have to think about, I know I have to go around 360 degrees. So I'm going to do 405 minus 360 to figure out what the other number is. And that's going to give me 45. So I'm going to go around the circle once, and then I'm going to end at 45 degrees. The question is, what do you notice about each of these? You should notice a couple things. You should notice, and I should give you more wait time, but we're not in class, so we're just going to keep moving on. Notice all end in Q1. All 45 degrees above positive x-axis. They all have the same terminal side. These angles would be considered coterminal. Think about what it means, what the parts of coterminal are. Terminal, when I think of terminal, I think about ending it, or I think about the terminal at the airport. When I'm going to the terminal, I tend to be leaving my vacation. It's the end of something, or it's the end of my time somewhere. Co, meaning two of, or you're doing it together. Not necessarily two, but you're running it together. If we have co-presidents, they're running it together. So coterminal angles in the same place, ending in the same place. So we're going to have a little definition here. Our definition will be angles graphed in standard position with the same terminal side. Okay? So, don't feel bad if it takes you a little while to understand this. That's okay. Coterminal angles tend to be one of the most challenging parts that we go over in this lesson. So we do have a little equation that you don't ever have to use, but it can be a shorthand. So we have theta, that's our angle, plus or minus, because we could go bigger or smaller, 360 degrees times k. And k is the number of rotations around, gotta make sure you can read that, the circle. So why do we use 360? If you look back here, 45 and negative 315, if you combine the two angles, so you take the blue angle and you put it on top of where the purple angle is, they're going to make a full circle. So we're going rotations around the circle. So let's just check to make sure the ones from above are correct. So let's take 45 plus a variable, we'll call it x, equals a negative 315. So how am I going to solve for x? I'm going to subtract 45 from both sides, so I'll get x equals a negative 360. So we would do 45 minus 360 equals negative 315. In this case, k is going to be 1 because we're only rotating around the circle once. And let's check 405. So we have 45 plus, let's give it a different variable, y equals 405. So what am I going to do to get y by itself? I'm going to subtract 45. So I'm going to get y equals a positive 360. So our equation would be 45 plus 360 equals 405. So again, we are using just 360, one rotation around the circle. But what if I give you 465 degrees? What does that look like? So we'll start with 45 again, plus, we'll give it a different variable, z equals 765. So what do I need to do to get z by itself? I'm going to subtract 45 from both sides, and I'm going to get z equals 720 degrees. Well, how is 720 related to 360? 720 is exactly 2 of 360. So that equals 360 times 2. What does that mean? That k here was 2. In the grand scheme of things, the k doesn't matter. It's just getting the idea that all of these angles start in the same place and they end in the same place. They might go around the circle in a different direction, or they might go around the circle more than once. So let's go over some examples, because today we're just focusing on degrees. So our angle is going to be 212 degrees, and we want one positive and one negative coterminal angle. So, for 212, I have 212 plus a positive coterminal angle, which means I need to get bigger, is going to be plus 360 degrees. K can be 1. So I'm going to get 572 degrees. If we drew them, both of them would end in the same place. Or I could go bigger, and I could do 212 plus 360, and instead of making K1, I can make K2. It's whatever I want, because I'm just giving an example of a positive coterminal angle. So we'll get 932 degrees. All three of these angles will start and end in the same place. Now I need these will be our positives. I remember to write that. And then this will be our negative. So I'll have 212, and I have to get negative. Well, 212 minus 360 will give me a negative number, and that's all I'm looking for, negative 148. I could do that same thing with 212 minus 360 times 2. I'm going to get a negative number that, again, the angle starts in the same place as 212 and ends in the same place as 212. So let's look at one more example, negative 513. So I have a positive one, negative 513, plus, if I add 360 once, is that going to get me to a positive number? Let's check. 513 plus 360 will give me a negative 513, will give me a negative 153. Is that a positive angle yet? No. So we're going to want to add 360 again. So how many times are we going around the circle? Twice. So now we're going to get 207 degrees. That's going to be a positive coterminal angle. Now we actually already stumbled upon our negative, but I'm going to go back and I'm going to write that out. What we just did. So you can see it written like the formula from above. Theta plus or minus 360 times k. Now my negative one. Now negative, I don't have to always subtract 360. I just need a negative number. So technically I've already done that. Negative 513 plus 360 gave me negative 153. That was a negative number. That's coterminal angles. So on the worksheet, you're going to want to do, I want to make sure it looks exactly. So numbers 27 through 42 on the worksheet. It's really important that you understand this with degrees because on Wednesday we're going to go over it with radians, and this is definitely more challenging than degrees.